Okay, let's break down Big O notation in plain English. Big O is a way to describe how much work an algorithm does as the input gets bigger, not in seconds or milliseconds, but in terms of how the work grows. Think of it like this. If you double the input, how much more work does the algorithm have to do? That's what Big O tells you. Let's say you have two programs that sort a list of names. One takes 1 second, the other takes 2 seconds. You might think the first one is better, but what if you give them a list of 1,000,000 names? Suddenly, the first one takes 10 seconds and the second one takes 10 hours. That's the kind of surprise Big O helps you avoid. It tells you how the algorithm scales, not how fast it runs on your laptop today. Now, what does the O mean? It stands for order of, and n is the size of your input. So O of n means the work grows in proportion to n. If n doubles, the work doubles. O of n squared means the work grows like n squared. If n doubles, the work quadruples. It's like a speed limit sign for how fast the work grows. Let's look at a simple example. Linear search. You're looking for a name in a list. Worst case, the name is last or not there at all, so you check every item. If the list has 10 items, you check 10. If it has 1,000, you check 1,000. That's O of n. The work grows linearly with the input. Now, what if the algorithm does 2n plus 5 steps? We still call it O of n. Why? Because when n is big, the plus 5 and times 2 don't matter much. Big O zooms out and focuses on the dominant term. It's like looking at a map from space. You only see the big roads. Also, Big O usually means worst case. If someone says an algorithm is O of n squared, they mean it won't get worse than n squared steps. But we can also talk about best case, which is written as omega of n, and average case, which is written as theta of n. For example, quicksort has an average case of O of n log n, but a worst case of O of n squared. Let's go through some common Big O classes. O of 1 is constant time. The work doesn't change with input size, like accessing array at I. O of log n is logarithmic. The work grows slowly, like binary search. You cut the problem in half each time. O of n is linear. The work grows directly with input, like scanning a list. O of n log n is a bit more than linear. That's what you get with efficient sorting, like merge sort. O of n squared is quadratic. That's what happens with nested loops, like bubble sort. O of 2 to the n is exponential. The work doubles with each extra input. That's what you get with brute force subset problems. O of n factorial is factorial. That's even worse, like checking every possible order of items, brute force permutations. Now, how do you find Big O from code? Here are some quick rules. One loop over n items, that's O of n. A loop inside a loop is O of n squared. Two separate loops, one after the other, still O of n. If you have an if-else, take the slower branch. If you're having the input each time, that's O of log n. Recursion? Depends on how the input shrinks. Here's an example. For I in range n, and inside that, for j in range n, print I and j. That's a nested loop, so it runs n times n, or O of n squared. Big O isn't just about time. It can also describe space, how much memory an algorithm uses. For example, a hash table gives you fast lookups in O of 1 time, but it uses O of n space to store the data. Now, here's what Big O is not. It doesn't tell you the exact time. It ignores constants, it doesn't care about your hardware or programming language, and for small inputs, it might not reflect real-world performance, but it's a powerful tool for thinking about scalability. So here's the one-sentence definition you can remember. Big O notation describes how an algorithm's time or space needs grow with input size, focusing on the dominant trend for large inputs, usually in the worst case. Picture a graph with input size on the x-axis and work on the y-axis. Big O tells you the shape of that curve. Is it a straight line? A curve that shoots up? A flat line? That's what you're learning to recognize. And here's a final tip. Don't stress about memorizing every Big O class. Focus on the intuition. Ask yourself, as the input grows, how does the work grow? That's the heart of Big O.